Hello, today I'm going to show you how to leverage TrueWatch log pipelines to make your logs more readable and searchable. I've set up an open source CRM instrumented with ddtrace, and I've deliberately modified some endpoints to generate errors. The app is running in AWS EKS with Datakit automatically collecting logs from standard. So now let's generate some errors and see how they appear in the TrueWatch console. Okay, now let's wait for the logs to come in. Okay, so you see we have some logs here. However, even though it seems like the log level is error, we can see from the main screen that the log is highlighted as blue color as the status is info. This is because in TrueWatch, the default field that is looked at is actually the status field. So if we want to translate the level error into status, we actually need to do a field mapping, and this can be done using log pipelines. So one good thing about this is that it allows us to transform the logs without changing the application code. So to create a log pipeline, we can go to this tab. Okay, over here, you can either choose a local pipeline or central pipeline. Choosing local means the log formatting is computed by the Datakit instance that's running alongside your app. Whereas choosing the central one means that the compute actually happens on TrueWatch side, which may incur additional costs. So in this demo, I'm going to choose local. So as for the source, we want to, let me delete the existing pipeline. Okay, now I can select Idura backend. We just have a limit of one pipeline per source, but that's only because of limitations of our demo workspace. Okay, as for the test samples, we can click this, get a sample, and this will just pull one of the more recent logs here. As you can see, this is one of the error logs as the level the log level is error here. So over here for test samples, you can actually add more than one. And then when you've written your passing rules, you can test them on each sample. Okay, as for the passing rules are written using Grok, which is a pattern matching tool. So if you have used the ELK stack before, this will feel quite familiar. So let me just write in the passing rules first. Okay, so I'm just going to quickly go over the rules that I've written. So basically what this JSON function does is that it extracts out the key level and then it assigns it to the new key of status. So we do that for the trace ID, and also if we check that if the status is error, we add another two keys which are error message and error stack. So now let's check if this is actually working. So we should expect to see a new error message as well as a error stack key here, and this is working properly. And we also added a trace ID. Oh, sorry, there's a typo here. Okay, nice. The trace ID is coming also. Yeah, okay, so we are not only mapping our level to status here, but we also are nesting the trace ID variable to make it easier to search. Okay, now let's save it and we can generate some more errors to see if it's working. So any log pipeline that you implement, just take note that only the logs ingested after you create the pipeline will have the changes applied to it. Okay, so I'll just wait for a little bit, and if the pipeline is working, we should be able to see error logs coming in, which are highlighted with a red column instead. Okay, so it took a while for the updated data to come in, but now the log pipeline changes have finally been effected. So now that I open up a new error log, I can see that while the level is error, the status is also error here. And also, initially the DD trace ID was nested within the DD object, but now we have also taken it out here as a level 1 nested key. So this actually makes it much easier to search for logs using the trace ID, and I'm going to demo that to you now. So I can just do this, and I'll be able to find my log directly. Whereas if the trace ID was still nested within the DD object, I wouldn't be able to query it this manner.